Hi there, my name's Ryan. I'm going to do a quick demo here of a ICD-10 health codes that have been fed into Watson NL classifier. What you're about to see is a post-training test. I did another video of the training earlier on. So if you want to see how to actually load them up and get the ground truth up to the classifiers before the stage, go and find that video. So I'm going to be jumping back into this R code again. We loaded all of the libraries that were here. Set the working directory. The credentials are loaded in. These are dummy credentials, of course. And then there's a bunch of functions here. One for creating the classifier, which we did in the last video. One for checking the classifier status, which we'll see shortly. Deleting classifier, which we won't need today, and then some heavy lifting in here to just list the classifiers and whatnot. So if we go and we list the classifiers and focus here, you can see that we've got 4 of them, A, B, C, and D. Each one of these classifiers has an identifier and a name. And if you want to go and find out where they came from, here's the ICD-10 health codes. This main CSV here has all 69,000 or so, and 0 to 20K, 20 to 40K, 40 to 60K, and the last one 60 to 69K. Each of these 4 ground truths was sent up to the NL classifier last night, chewed down that overnight, and has now created these classifiers that are ready for business. So if we go and we highlight this first one, for example, and we ask for the status. Let's go down here. Actually, I've jumped ahead a little bit. So, so we can see all the classifiers here have already been trained. This I'm not going to do today. I did this last night, but this is setting the file to focus at for the ground truth, and then the actual name of the file. And then I went through and last night I ran this 4 times to create a new classifier for each one of these 4, and it'll be in a training state for a period of time, depending on the size of the ground truth, and then it'll become available, which it is now, because we can see that those classifiers are both visible, and as we'll see shortly, that they're available and ready for use. So we're not going to do this again because we did that last night. So we've got our classifiers here. And here are the 4 classifiers. So I'm taking classifier A, B, C, and D, and I'm mapping in our classifier identifiers that was assigned. The names are given by us. The classifiers are assigned by the system. So let's load in A, B, C, and D, and then we can check the classifier status for each one of them. And you can see that the language here says that the classifier is now available and ready to take classifier requests. And we check B, C, and D, and all 4 of them are ready to go. So let's try one out. So in this case, we're going to load some text called query. Somebody slipped on an ice and fractured their skull, and I'm going to run this through each of the 4 of the classifiers. And you can see we got a class group returned and a confidence interval. This one has 17%, 10%. The cumulative confidence here will add up to 100%. Now this is just for classifier A. We need to run the same for B and C and D. And you can see D has actually come up with a 22%, a W011. Now these classes map over to our master list here of 69,000 ICD-10 codes. So we can actually go and have a look at class W011, W011. And actually this one came up pretty good. So we've got a fall from a level, slipping and tripping and stumbling and striking. So we've gotten into the right grouping here. It hasn't. The whole point of the classifier is not to actually find a one-to-one correlation, but to find the class. And in this case, the class or the group is the W011 group. And if we're trying to find a correct diagnosis or down select for our top 5 or 6 candidates for the healthcare workers to do, this would be a good place to start. We can also go see what our second best bet here was, Z183. And keep in mind, we're just looking at within this one classifier here. So let's have a look. Yeah, not so good on this one. And let's have a look on T159. And as well. So, they're not all perfect here, as you'll see in the subsequent examples. So to make this go a little further, we're going to create a function here that runs all 4 of these classifier queries. and then stores the results in data A, B, C, and D, and then binds all of them together. So let's create this function, and we'll run it again on our ice slipping example. And we've already seen W01 and 1. We've got H833 here, so let's go see what that gives us. And that, not ideal. And then T159. The T159 family, we've got foreign bodies. So probably our first and best ones there. There may be better classes, but again, this is just an example to get a feel for strengths and weaknesses for the classifier. As with machine learning, the architecture should take into account there will be errors and architect it in a way to improve and update the ground truth over time. So let's try another one here, Streptococcus pneumonia, and let's run this again. This is a pretty specific language here. So Z223, and here we are in the Z223 grouping. We've got to Streptococcus, so that's good there. And let's go and see what the next highest one here, A403, and that gets us here to Streptococcus. So this one did pretty well, given there's a verbatim piece here. Now, you could also combine this with grepping for an exact word match in cases where there is an exact language or word, using it to down select what's in here to get you to the right zip code. There are other methods, or in some cases using all of the methods may be the best architecture. I think where the strength of the NLC may be showing is in areas where the exact word matches is not in there, but where the idea is closer to sort of down select based on that. And we'll see that in some of the other examples here. Let's do left ear shot off with a laser gun. And here we are. S013. Let's go see this one. S013. So there's a lot of them here. Unspecified. Well, we got the ear, the left ear trauma, and there's actually quite a few S013s that are in here. I won't look through all of them, but there is a reasonable one here. And W902. Oops. And this one's got the laserness of it. So one focused on the ear and the other one focused on the exposure to laser radiation here. Let's do another one. How about cat bite on the left leg? W550. This one's pretty tight. Cat bite. Let's see what the next highest one here. Q722. Not really helpful here. Just for grins, let's go for the third one, T246. So let's go bite on the ear from a horse. Again, we've got our 551, W551. And again, these are horse, oh, there we are. Yeah, a horse bite. So these animal bites are performing quite well. Very sort of unique gravity wells within the knowledge graph. Rapid heart rate and chest pain. I'll do a few more here. Z or Z952. Not so good on that first one. Prosthetic heart R078. I think this is actually fairly relevant. And let's go for the third one here, S225. Maybe not so much. So And let's do one more here. Alcohol and drug consumption leading to confusion and lethargy. M871. And let's have a look here. Drug use, although these tend to be sort of trauma. And let's see what T519 gives us. Toxic effect of unspecified alcohol. And this is probably in a pretty decent range here. So again, that was just a quick overview of a raw set of data thrown up on the NLC to see how it would perform. Let's do one more.